Okay, the last couple here, second part of 8.2 video. This next one, number 4, it's a definite integral, so we're going to have to evaluate it at the end. First thing is we do not have an integration rule for ln of x. We have a derivative rule for it, but not an integration rule. So u substitution, or excuse me, integration by parts. We're going to let u equal the ln of x. That means du is equal to 1 over x dx. The remaining part is going to be dv. Well, what's left is just a 1 dx. And then when we integrate that, so the integral of dv is v, and the integral of 1 is just going to be an x. And I got to be careful with my v's and my u's. Okay, so now when I go to write this, it's going to be u times v, which is x ln of x minus the integral of v, which is an x, times du, which is 1 over x dx. And I can simplify this over here. The x's cancel out, so this makes it fairly easy. X ln of x minus the integral of 1 is going to be an x. I'm not going to put a plus c because I'm going to evaluate it from 1 to e of that value. Alright, so let's see. If I plug in e, so I'll come over here. That's going to be e ln of e minus e minus, and I'll put a 1 in, so it's going to be the ln of 1 minus 1. F of e minus f of a. So the ln of e is 1, so this is just going to be e minus e, minus the ln of 1 is 0, minus 1. And e and a negative e are going to cancel out, and that's going to leave me with 1 as my answer. Okay, last couple here. Again, make u the simpler part, and then the dv will be the more complicated part. So u is going to be equal to x, du is equal to 1 dx, dv is going to be equal to the sine of x dx, and then when I integrate both of those, I'm going to get v. The integral of sine is negative cosine x, and now it's u times v, so x, I'll put the negative out in front, u times v minus the integral of v, which is a negative cosine x. Make that a plus there. And what do I need next? Du. Du is just a 1 dx. So now I get negative x cosine x. The integral of cosine is sine, so plus sine x plus c. Done. Okay, I believe this next one is we have to do it twice. Okay, I paused there for a second because I didn't think I was recording. Hopefully this is. Alright, so u is going to be equal to x squared, du is equal to 2x, dx, dv is going to be equal to the cosine of x dx. Integrate that. So the integral is a v. The integral of cosine is a sine x, and then plus c, but plus c. So now we do u times v. So u times v minus the integral of v, and then du, which is going to be times 2x dx. Again, when we go through to do this, this part we're not going to be able to integrate. Even if you did u substitution, it's not going to match up. So we have to do u for this one is going to be 2x, du is equal to 2 dx, dv is equal to the sine of x dx, and then when I go to integrate both of those sides, I'm going to get v is equal to a negative cosine x, and then plus c. Alright, I'm going to erase some of this over on this side here so I can use this space. Okay. All right, so let's get back to this part down here. So just this part here, I'm going to do u times v. So that's going to be 2x negative cosine x minus the integral of v, which is going to be negative cosine x. So it's going to make that a positive. And then du is going to be a 2 dx. So now I can recopy this problem. Come all the way over here. So we have our original part here, which is x squared sine x minus the quantity of this part down here, which is going to be negative 2x cosine x plus the integral of 2 cosine x dx. Alright, and now I can go through and simplify that. So let's see. X squared sine x, that should become a plus 2x cosine x. And now when I go to integrate this, the 2 will come out, and when you integrate cosine, it becomes negative. Does it become negative? Now it's going to stay positive, but this is going to switch it. That's what happens there. So a sine x plus c, and I got to switch this sign to negative right there. So let me just erase that. Minus 2. And again, the reason why that becomes negative is that right there. And there is your solution. Okay, last one. All right, this one is kind of a challenge, and there's a lot going on with this one, a lot of things that you have to do. But we'll give it a shot. All right, so the first step with this, and again, when we have our quiz, I'm not going to make anything this difficult, but it's an interesting problem. All right, so the first thing I'm going to do is rewrite this as a secant x times a secant squared x dx. And then I can do integration by parts. So I'm going to let u equal the easier part, which is the secant x. Therefore, du, the derivative of secant is secant x tangent x dx. Then dv is going to be secant squared x dx. And now when I integrate those, I get a v. The integral of secant squared x dx is tangent x. All right, so now I'm going to rewrite this. So, and I'm going to rewrite what the original problem was, and you'll see in a second why I'm doing that. So it's going to be u times v. So secant x tangent x minus the integral of v, which again is another tangent x, and then times du, which is secant x tangent x dx. All right, rewrite this a little bit. Again, secant x tangent x minus the integral of tangent times a tangent's a tangent squared x secant x dx. I'm going to rewrite tangent square x, use one of the identities. So that becomes secant x tangent x integrate. Tangent squared x is, well, we know that 1 plus tangent squared x equals secant squared x. That's an x. So tangent squared x is going to be equal to, that secant x is for that one, and then times the quantity. Tangent squared x is going to be secant squared x minus 1 dx. And the next thing I'm going to do is, there should be a minus sign in there. Minus, I'm going to distribute that in and get a secant cubed x minus a secant x dx. All right, I'm going to break those apart. Secant x tangent x minus the quantity, the integral of secant cubed x dx minus the integral of secant x dx. And without having to write this whole thing over again, I'm going to distribute the negative in here, so that'll be negative, and then that'll make this a positive. Now I'm going to bring this down here. You're going to see why in a second. Secant cubed x dx. I'm going to move this integral over to the other side and have like term integrals. So when I move that over, I'm going to get two integrals of secant cubed x dx is equal to secant x tangent x plus the integral of secant x, if I could write. That says secant there. It's kind of messy, but alright, so now I get a secant x tangent x, and then the integral of secant x, if you remember this one, is the ln of the absolute value of secant x plus tangent x plus c. And the last thing you have to do is, because we want to know what the integral of secant cubed x is, not twice it, so I have to divide everything by 2. So this answer is going to be basically this whole thing divided by 2. Okay? And that is your solution done. And the last thing I want to do is just thank you for a great year. You're great kids. I enjoyed it. Even enjoyed having love in class. It was good. You need good characters in your class. And I wish you all the best of luck next year with whatever you're doing, going to college and in the future. I'm sure I'll run into some of you some weird places. So good luck and enjoy the rest of the end of the school year here. Okay? Thanks.